Hello, in this video we're finishing off our lesson on significance tests for population proportions. So we're looking at example number 2, and it says, according to the Centers for Disease Control and Prevention website, 50% of high school students have never smoked a cigarette. Josh wonders whether this national result holds true for his large urban high school. Josh surveys an SRS of 150 students from his school. He gets results. From all students surveyed, 90 say that they have never smoked a cigarette. What can Josh conclude? So I made a note at the end of class that this is a two-sided alternative hypothesis. Therefore, we need to look at both tails, and the p-value is going to be 2 times the normal CDF. So we might wonder why this example is two-sided and our example with the potato chips was only one-sided. In this case, because of course we know that in his school, 90 out of 150, we know which side of 50% that is on. So why wouldn't we go with just one-sided? Well, the answer is we are supposed to be choosing whether it's one-sided or two-sided before we do our sample. So if you assume that we don't know this 90 number, all we know is he's planning to do a SRS of 150 students. He wants to know whether the national results hold true for his particular high school. So he does not know yet whether his school is exactly 50%, if it's lower, or if it's higher. In the case of the potato chip company, they were looking at whether they were rejecting truckloads of potatoes that had more than 8% blemishes. So if they had fewer than 8% blemishes, that's great for them. So that is why that one's a one-sided one. This one is two-sided. Okay, so let's get on with this one. We're doing our 4-step process, so the first thing to do is to state. Now, since alpha is not provided, we will use the standard value of 0.05. We want to perform a significance test. And this is a proportional z-test. For a proportion, where the P is the proportion of students who never smoked cigarettes. So our null hypothesis is going to be that the proportion equals 0.50, and our alternative hypothesis is that the proportion is not equal to 0.5. All right, that's our statement. Our plan. We need to test our 3 conditions. So RIN. First is random, and from our information it has been stated that this is an SRS, so that condition is satisfied. Independent, this is sampling without replacement. And so we need to check that our N, which is 150, is less than or equal to 1/10 of our population value. And so it is reasonable to assume a large urban school or large urban high school has more than 1,500 students. Okay, so that one we've checked off as well. And now the normal condition. Now remember, this is proportions, so we're not going to look at n being greater than 30. That's for means. We are looking at n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So 150 times 0.5 is 75, which indeed is greater than or equal to, and 150 minus times 1 minus 0.5 is again 75, which is greater than or equal to 10. So don't forget to make your actual statement. Since both are greater than or equal to 10, it is safe to use normal calculations. Oops. So we can check that one as well. All right, next step, D. First we need to calculate our sample proportion. So 90 over 150 equals 0.6. Then we need to find our test statistic. Z, which equals p cap minus p over the square root of p times 1 minus p over n. So 0.6 minus 0.5 over the square root of 0.5 times 1 minus 0.5 over 150. And so we get a Z value of approximately 2.45. Now, this is if we're looking at our standardized distribution, it's two-sided. So we're looking at 2.45 and negative 2.45, and we're looking at the probability of getting a value, standardized value, further from 0 in both cases. So we're going to calculate 2 times the normal CDF, and we're taking the normal CDF of negative E99, negative 2.45, 0, and 1. And of course you could have done positives and switched the order around to look at the right-hand tail instead of the left. So we're doing the 2 times because it's a two-tailed test. Okay, so we end up with 2 times 0.007, which equals 0.014. So, to make our conclusion, we need to check, is our p-value we need to compare our p-value to alpha. So in this case, our p-value is 0.014, which is less than alpha of 0.05. And we'll use the space here to conclude. Conclude that at the 5% level of significance, there is convincing evidence that the smoking rate at Josh's high school differs from the national average of 50%. Okay, so we've shown our calculations for the sample probability, proportion, and for our test statistic, and then we showed using the normal CDF, where this is our min and our max, our mean, and our standard deviation, and that's normalized. There is a shortcut here, and once again, if you use shortcuts on your calculator, you need to always state your values, and what it pops up, you need to, with numbers, you need to list them out as